Hello, everyone. Today we're going to do packet tracer of CCNA2 version 7.2.10. Packet tracer configure DHCPv4. V4 is version 4. Here's the addressing table. Device include 3 routers, 2 PCs, DNA server. So 3 routers, router 1, router 2, router 3, and 2 PCs. And DNA server is here. Okay, and the objectives: part 1, configure a router as a DHCP server. Part 2, configure DHCP relay. Part 3, configure a router as a DHCP client. Part 4, verify DHCP and connectivity. Scenario: a dedicated DHCP server is scalable and relatively easy to manage, but it can be costly to have one at every location in a network. However, a Cisco router can be configured to provide DHCP services without the need for a dedicated server. As the network technician for your company, you have been assigned the task of configuring a Cisco router as a DHCP server. You are also required to configure the edge router as a DHCP client so that it receives an IP address from the ISP network. ISP is the Internet Service Provider. Here's the edge router. So in this topology, we can see that R2 is the edge router because R2 are directly connected to the local LAN network. Here, LAN network, R1 LAN, R3 LAN, and also R2 is also directly connected to outside the internet. So R2 is edge router. Instructions: part 1, configure a router as a DHCP server. Step 1, configure the excluded IP addresses. Here, why do we need to configure excluded IP address? So here, DHCP server, DHCP stands for Dynamic Host Configuration Protocol. DHCP server is the server that will automatically or dynamically provide the devices with its IP address. But in the network, there are still some devices that need to be assigned IP address manually or statically. So for those devices that need to be assigned IP address manually, we need to exclude some IP address for them for their static assignment. So here, addresses that have been statically assigned to devices in the network that will use DHCP must be excluded from the DHCP pools. This avoids errors associated with the duplicate IP addresses. In this case, the IP addresses of the R1 and R3 LAN interfaces must be excluded for DHCP. The LAN interface, R1, R3, LAN interface is the interface that is directly connected to the local LAN network or the end users. So on R1, this interface should be the LAN interface. It is also called a default gateway. R3 is this one, the LAN interface. Because the default gateway need to be manually configured IP address. So this LAN interface or default gateway interface need to be excluded from DHCP. In addition, 9 other addresses are excluded for static assignment to other devices such servers and device management interfaces. So there will be 10 addresses are excluded for the static assignment. So A, configure R2 to exclude the first 10 addresses from the R1 LAN. R1 LAN is this LAN network, which is 192.168.10.0/24. Okay, let's go to R2. Let's configure excluded address. So enable configure terminal, and we use command IP DHCP excluded address. The first 10 IP address for this network, R1 network, is from 10.1 to 10.10. Okay, it's followed by the first excluded IP address 192.168.10.1, then followed by the last excluded IP address, or the 10th excluded IP address is 192.168.10.10. So first 10 IP address will be excluded for the static assignment. This is for the R1 LAN network. Next is configure R2 to exclude the first 10 IP addresses from R3 LAN. This is R3 LAN network, 192.168.30.0/24. So the first 10 IP address should be 30.1 to 30.10. Okay, I use up arrow. This time is for the R3 LAN. So here is 30.1. The first excluded IP address is 30.1. And the last one is 30.10. 30.10. Okay, so we finished step 1. Step 2, create a DHCP pool on R2 for the R1 LAN. Create a DHCP pool named R1-LAN, case sensitive. Case sensitive, so all the letters are capital. Let's go to configure the DHCP pool name. So we use command IP DHCP pool followed by the pool name, which is called capital R1-LAN. It's case sensitive. All letters are capital. R1 LAN. After configure the pool name, we need to configure the DHCP pool to include the network address, the default gateway, and the IP address of the DNS server. So first, the network. So network is 192.168.10.0. Followed by the subnet mask is 255.255.255.0. Then we need to include the default gateway IP address. We use command default router. Default router 192.168.10.1 is the default gateway. So remember here, the excluded 10 IP address here, 10.1 to 10.10. So 10.1 is the first excluded IP address for default gateway. The next, the DNS server IP address is 192.168.20.254. Okay, we finished step 2. Step 3 is create this DHCP pool for R3 LAN. Okay, create a name R3 LAN. Then include the network address, default gateway, IP address of a DNS server. They do the same thing. Okay, I'm going to use up arrow. This time is R3 LAN. The pool names are R3 LAN. Okay, here are R3 LAN. The network, I use up arrow again. Network, this time the network is 30.0. 30.0 because our R3 LAN is 30.0. And the default router, default gateway, default router is 30.1. And the DNS server IP address is the same. Okay. Okay, So we finished step 3. Okay, we finished part 1. Part 2, configure DHCP relay. Step 1, configure R1 and R3 as a DHCP relay agent. R1, R3 as DHCP relay agent. Okay, for DHCP clients to obtain an IP address from a server. Here, DHCP client refers to the PC1 and PC2. To obtain an IP address from a server. Server is a DHCP server we just configured on R2 on a different LAN segment. Yeah, R2 and the PC1 are in 2 different LAN segments. So the interface that the clients, these are the PCs, are attached to must include a helper address pointing to the DHCP server. In this case, the hosts on the LANs that are attached to R1 and R3 will access the DHCP server. The host will access DHCP server R2 through R1 and R3. Okay, so IP address of the R2 serial interfaces that are attached to R1 and R3 are used as the helper address. So the serial interface, these 2 serial interface on R2 are attached to R1 and R3. So these 2 serial interface will be used as a helper address. Okay, DHCP traffic from the hosts on the R1, R3 LAN will be forwarded to these addresses and processed by the DHCP server that is configured on R2. Okay, A, configure the helper address for the LAN interface on R1. LAN interface, let me go here. Okay, so on R1, the LAN interface is G00, which is also called the default gateway. Okay, we need to configure helper address on G00. Okay, go to R1. So enable configure terminal interface G00. That is a default gateway or LAN interface. Okay, so we're going to configure helper address on this LAN interface. Helper address for the R1 LAN, the helper address is S000. For R3 LAN, the helper address is S001. These 2 serial interface would be the helper address. So here, command IP DHCP, IP helper address is here is a 10.1.1.2. So here we're on the R1. S2 S000, the IP address is 10.1.1.2. This is a helper address. Okay. Next, we configure helper address for LAN interface on R3. R3 LAN interface is G00. Helper address is S001. So enable configure terminal interface G00. That is a LAN interface, and the IP helper address, which is S001. Okay, here R2 S001 is 10.2.2.2. Okay, 10.2.2.2. Okay, we configure the helper address on the LAN interface. So next step is is we can, step 2, configure hosts to receive IP address information from DHCP. So now we can configure PC1, PC2 to receive IP address from this server. Okay, hold on, maybe. All right, from this DHCP server R2. So PC1, go to IP configuration. Right now it's a static. We use DHCP right now for PC1 IP address. So click requesting IP address. So now PC1 get an IP address 192.168.10.11. Remember, we excluded first 10 IP address for static assignment. So the 11th, so the first available DHCP address is 10.11. So PC1 take the first available DHCP IP address, 10.11, as its IP address. So subnet mask 255.255.255.10, default gateway is 192.168.10.1. DNS servers 20.254. This we configured manually already. So we're going to verify PC1's IP address. We close here. Here we are in the configuration window. So we go to command prompt to verify. We use command ipconfig /all. You will know why I use /all. Here, IPv4 address of PC1 is 10.11. Because subnet mask is this, and default gateway is 10.1. Okay, DHCP server is 10.1.1.2 is also the helper address. Remember that helper address is this one. It is DHCP server's IP address. Okay, we finished PC1, then go to PC2, IP configuration, DHCP requesting IP address, yes. So PC2 got an IP address 30.11. Okay, still we excluded the first 10 IP address for static assignment. So PC2 take the first available DHCP IP address, which is 30.11 as its IP address. So default gateway 30.1 is correct. DNS server is this one we manually configured. Again, let's go to verify PC2's IP address. We do the same thing, ipconfig /all. So PC2's IP address 30.11. Okay, subnet mask is same. Default gateway 30.1, good. DHCP server's IP address 10.2.2.2, which is the helper address as well. Okay, it's correct. So we finished this part 2. Part 3 is configure router as a DHCP client. Here the router should be the R2H router as a DHCP client. So R2 will receive an IP address from ISP, okay, automatically because it's through DHCP. So R2 become a DHCP client. Just as a PC is able to receive an IP address from a server, a router interface has the ability to do the same. Router 2 needs to be configured to receive addressing from ISP. ISP is in the internet. Okay, A, configure the gigabit Ethernet 01 interface on R2 to receive IP address from DHCP and activate the interface. So it should be this interface, G01. Let's go to G01, this interface. G01 will be configured as DHCP client. Okay, let's go to So interface G01 on R2 is correct, G01, and the IP address DHCP, good. Then no shutdown to activate the interface, no shutdown. So use packet switcher fast forward time feature to speed up the process. Okay, here it's turned gray now. And let's go to get a fast process. Okay. So next we need to use show IP interface brave command to verify R2 received an IP address from DHCP. Okay, go back to the executive mode. So show IP interface brave. So look at here, G01, get an IP address. Okay, the method is DHCP, good, up, because we no shutdown to turn on the interface. So correct. So part 4, verify DHCP and connectivity. Step 1, verify DHCP bindings. R2, show IP DHCP binding. Okay, let's go to show IP in DHCP binding. Binding IP address. This hardware address should be in the MAC address. So this IP address should be PC1's IP address. This should be PC1's MAC address. This is PC2's IP address. This is PC2's MAC address. We can verify from here too. Okay, here's PC1. IP address 10.11 is correct, 10.11. And MAC address, the physical address is MAC address 0002-4885-1470 is here, 0002-4885-1470. Okay, it's correct. And PC2 MAC address is here, 0004-9897-2535. 0004-9897-2535. And this is PC2's IP address, 30.11. Here, 30.11 is correct. Correct. Verify configuration. PC1, PC2 can ping each other at all other devices. Let's ping PC1, ping PC2. PC2's IP address is here, 30.11. Let's ping PC1 to PC2 is 192.168.30.11. Should be successful. Success, good. So then ping DNS server. Ping DNS server. DNS server's IP address is here, 20.254. Yeah, it's here, DNS server. Ping 192.168.20.254. DNS server is here. Yeah, success. And then let's ping the two servers. Ping www.cisco.com. Let's ping this one, Cisco, the server. Success. Then ping the public sites. Ping www.publicsite.com. Success. Okay, perfect. And here the completion status is 100%. So that means we perfectly finished this package or configured DHCPv4. Thank you for watching my video. If you like my video, please thumbs up and subscribe my channel and leave comments and share with your friends. See you next time.